Hey guys, welcome to the video walkthrough for question number 3, Lagrange interpolation. The first part of the question is just kind of like developing an intuition for the formula that Lagrange came up, that Lagrange is. The question is basically there's a polynomial with degree 2, px polynomial over mod 7. So basically the space I'm working is mod 7. Then they gave these 3 points on the polynomial, on the 2-degree polynomial. And then they also said that there are 3 polynomials of degree 2, p1, p2, p3, and they satisfy these points. So the first part is pretty straightforward. They're just asking how can we express p, which is our main polynomial, in terms of p1, p2, p3. One thing to note is that p1, like right here, at 1 is 1, but in my original polynomial it's 2. So I'll need to multiply by 2. Same for the second p2. It's 1 at 2 and it's 1 at 2 as well, like in the original and in the p2 version of it. So we do not change it. And then right here, p3 at 3 is 1. But the original p at 3 is 4, so we need to multiply it by 4 to account for that. Next up, we got that we need to find the coefficient representation for p1, which is 2-degree polynomial. And we need to show, basically, in the question it says that it's of the form c times x2, x minus 2, x minus 1. So basically, we can see from the first point right here that it's 0 at 2x positions, 2 and 3. So I can definitely write that. And then I can also see that it is a 2-degree polynomial. It must have some constant c. Okay, that was also intuitive because from 1 we can see that p1 is 0 at 2, 3. Okay, then we have part C. What is the value of C? What is like the actual coefficient representation of P1? So what we're trying to do is basically we need to find a C value such that it will make it equal to 1 at x is equal to 1. So C is 1 minus 2, because x value is 3 right now, and we are supposed to make, sorry, not 3, 1 right now, and then we're supposed to make it 1, as we can see from 1, like this equation 1. So how we can do this is, first let's find what this is. It's basically 2 in mod 7 space. And then all we need to do is that find some c that's like gonna give me a 1 in mod 7 space. So if you just do it like kind of like a brute force approach, so if I take c as 1, I'm gonna get like 2, which is not 1 clearly. If I take c as 2, I'm gonna get 4. If I take c as 3, I get 1. Oh, not 1. 6. And then if I take c as 4, I'm gonna get 1. So c is 4. And then you can plug this value in here to give you the polynomial, which turns out to be 4x squared plus x plus 3. And then similarly, we can do this for part D as well. I can show the zeros. So C x minus this one is 0 at x is equal to 1, and it's at x is equal to 3, and then P3 is 0 at x is equal to 1 and x is equal to 2. So these are the equations. You need to find such an x such that it'll give me a 1. Okay, and then at the end of the solution, I'm just gonna add whatever I find with my initial solution that I found in part A to give my main polynomial. Okay. Coming to part 2 of the same question. The first part was kind of like a intuition building thing, and this is the same question, just we're gonna do it with the Lagrange formula. So these are the 3 points. Again, these are the same points as we had above. 1, 2, 2, 1, 3, 4, 1, 2, 2, 1, 3, 4. And the same mod space, which is 7. So do you guys see how we basically like to find the polynomial? We had like for P1, we had like x minus 2, x minus 3 over is basically used as like a inverse kind of thing. So you know how right here we found the inverse of this value. So we just write that here. And then we also need to account for this 2 right here. So I'm gonna add a 2 here. And then I'm gonna add this one. This one is from here. And then again I do what I was doing. X minus 1, x minus 3. Over is again just a way to write down inverse. And then I add this 4. And I write down my P3, which is so solving this would give me the same polynomial. Again, this basically, if I solve this, I'm gonna get say like 2 times 1. So I need to find inverse of 2 in mod 7 space. But yeah, that is Lagrange for you. Thanks for watching.